Hi, so what we're going to do today, we're going to talk about solving a system of equations by the addition method. Now, on this particular problem, this is going to be a little trickier just because we have fractions. Now, with fractions, you got to be very careful with it because you definitely want to make sure that you pick the correct numbers to multiply and, of course, the correct numbers to get rid of. So, in this particular problem, now you can pick whichever variable you want to get rid of. Does not matter. It's just you have to be able to multiply one or both of your equations by a particular number so that your variable goes to 0 when you add them up. So let's see here. In this particular problem, I would like to get rid of my x values. So basically, when I add up my equations, I want my x values to go to 0, and then my y values, and then these numbers would be something else. So in order for me to rearrange this to where my x values go to 0, well, first things first, I have 3/4 x plus 2/5 y is equal to negative 3/20, and a 3/2 x minus 1/4 y is equal to 3/4. Those are my original equations. So what I'm going to do, I'm going to take the bottom fraction and I'm going to multiply that by 1/2. Okay? Now, when I multiply the bottom fraction by 1/2, well, let me write out my original fraction. On the top, I still have 3/4 x plus 2/5 y equals a negative 3/20. Now, when I multiply 1/2 by every term in this equation right here, well, 1/2 times 3/2, well, that gives us a 3/4x. Then a 1/2 times a negative 1/4, well, that gets me a negative 1/8y equals 1/2 times a 3/4, well, that gets me a 3/8. Okay, now the problem is, if I add these guys up, my x values don't cancel out. They do not go to 0. So I have a problem. But in order for me to figure out the answers to that problem, I'm going to take this 1/2 and I'm going to make it negative. So I'm going to multiply everything by a negative 1/2. Now, when I do that, this negative 1/2 times 3/2, well, that gets me a negative 3/4. A negative 1/2 times a negative 1/4, well, that gets me a positive 1/8. Now, negative 1/2 times 3/4, well, that gets me a negative 3/8. Okay? When you solve a system of equations, especially by the addition method, a lot of times it is trial and error. You are going to mess up, but then it's okay. You just got to rework it again. So now, whenever I add up my terms, well, a positive 3/4x minus 3/4x minus 3/4x, there we go, well, that goes to 0. So now all I have left is a 2/5y plus 1/8y equals a negative 3/20 minus 3/8. Okay? So now what I have to do, I have to find the least common denominator between both of these guys and a least common denominator between both of these guys. So in other words, I'm going to have to add and subtract fractions. So to find the least common denominator between these two terms, well, LCD between 5 and 8, well, that's going to be 40. Okay? 5 times 8 gets me 40, and then 8 times 2, well, that gets me a 16. 8 times 5 gets me 40, and then 5 times 1, well, that gets me a 5. So now 16 over 40y plus 5 over 40y, well, that gets me a 21 over 40y equals. Now to do these guys over here, a negative 3 over 20 minus 3 over 8. Well, if you find the least common denominator between these two terms, well, the LCD between 20 and 8, ironically, that's going to be 40 as well. So 20 times 2 gets me 40, and then 2 times 3, that's where that 6 comes from. 8 times 5 gets me 40, and then 5 times 3, that gets you a 15. So now we have a negative 6 over 40 minus 15 over 40. Well, a negative 6 minus 15, well, that gets you a negative 21 over 40. All right. Now we're getting somewhere. So in order to get y by itself, you can either A, multiply both sides by the reciprocal of 21 over 40, or you can divide both sides by 21 over 40. Since we're dividing fractions, the easiest thing to do is multiply both sides by the reciprocal, which in this case would be 40 over 21. So what we do to one side, we got to do to the other. So now 40 over 21 reduces with this 40 and 21 here. So we would have y equals negative 21 over 40 times 40 over 21. Well, these 40s cancel out, and these 21s cancel out, but you're still left with that negative sign. So in other words, when everything cancels out, all you're left with is a negative 1 for your y value. Okay? So now that we have a y value of a negative 1, that's half of our battle right there. That's half the answer. Now we have to go back and figure out what our x value is. So we can plug the y value into any one of our original equations to figure out what our x value is. So I'm going to take my y value and I'm going to plug it in for, let's say, the second equation. You can also do it to the first equation if you like, but the second equation looks a little bit easier, looks a little bit friendlier. So my second equation was 3 over 2x minus 1 over 4y equals 3 over 4. Now, I'm going to take my y value of negative 1, and I'm going to plug in negative 1 in place of y. So what I would have is a 3 over 2x minus 1 over 4 times negative 1 equals 3 over 4. So to clean this up, 3 over 4x, a minus and a minus becomes a positive. 1/4 times 1, well, that gets me a 1/4. And that equals 3 over 4. So now we got to solve for x. We got to get our x value ultimately by itself. So in order for us to do this, we're going to subtract a 1/4 from both sides. So now we would have, these 1/4 would cancel out, 3 over 4x equals a 3 over 4 minus 1 over 4. Well, 3 over 4 minus 1 over 4, well, that gets us a 2 over 4. Okay, now generally from here, we would actually reduce this 2 over 4 to a 1/2. However, I wouldn't recommend it. The reason why, we still have this 3 over 4 left over. So in order for us to get rid of this 3 over 4, basically we have to get x by itself. We would do the same thing that we did on the y value. Multiply by the reciprocal, which is 4 over 3. Okay, so your 3's cancel out, your 4's cancel out, and all you're left with is x. Now here, this is why we did not reduce that 2 over 4, because the 4's here would cancel out. So that makes your multiplication a little bit easier. So we have your x value of a positive 2/3. Okay? Now, if you were to reduce that 2 over 4 to a 1/2, you would have 1/2 times 4 over 3. So you could reduce if you want to. The 2 would go away and the 4 would change to a 2. So you'd be left with a 2 over 3. Okay? It's just a little bit easier to see just the 4's canceling out. But regardless of which way you do it, you still end up with the same answer. So the bottom line, we have our solution set as your x value of 2 over 3 and your y value of a negative 1. With fractions, it's a little complicated, just as I mentioned before, but you have to be very careful on the fractions that you choose.